In section 8.3, methods of proving triangles similar, we will be doing just that. We used to prove that triangles were congruent based on various postulates. In this section, we'll learn various postulates and theorems to prove that two triangles are similar. The first postulate is, if there exists a correspondence between the two vertices of triangles such that the three angles of one triangle are congruent to the corresponding angles of the other triangle, then the triangles are similar. So in this postulate, you must prove that all three angles are indeed congruent. That will prove then that the triangles are similar. The first theorem that we're going to learn in this section, Theorem 62, is kind of a play on the postulate and the no-choice theorem. The theorem states, if there exists a correspondence between the two vertices of two triangles, such that two angles of one triangle are congruent to the corresponding angles of the other, the triangles are similar. Again, because of the no-choice theorem, you know that if you have two angles, the third one must be congruent, and that goes back to the previous postulate. Theorem 63 states, if there exists a correspondence between the vertices of two triangles such that the ratios of the measures of corresponding sides are equal, then the triangles are similar. And we can abbreviate this with side, side, similar. Now again, you might notice that this is similar to the congruency of side, 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 but it's important that we put the tilde sign to imply that it's similar and not congruent. You can see by this example that this would prove side, side, side similar. You can see right here how if I take each one of the sides, 1 over 3, that would be congruent to 3 over 9, because 3 over 9 reduces to 1 over 3. And the same with 5 over 15, since 5 over 15 also reduces to 1 over 3. So again, once you write them as proportions and they're equal, you can establish side, 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 similar. Theorem 64, the last one for similar triangles, is if there exists a correspondence between the vertices of two triangles such that the ratios of the measures of two pairs of corresponding sides are equal and the included angles are congruent, then the triangles are similar. So in this case, just like side angle side, the angle has to be kind of sandwiched in between the other two sides. But this time, instead of the sides being congruent, just like in the previous theorem, you just prove that the ratios of the sides are congruent. We'll be looking at 3 examples today of how to use or prove similar triangles. Looking at the first example, we're given that ACDF is a parallelogram, that angle 1 is congruent to angle 2, and what we're trying to prove is that angle AFB is similar to triangle DCE. Now, if you see the angle 1 and angle 2, they're part of a straight line. So what we can first say is that ABF is supplementary to angle 2, and angle DEC is supplementary to angle 1. And because they're both supplementary to congruent angles, we can then say that those two angles are then congruent. Then if we think about what we know about parallelograms, we know that the opposite angles are congruent. So we know that angle A is congruent to angle D because opposite angles of parallelograms are congruent. And right there, you'll notice we have two angles from the triangle are congruent, and then that will establish the similar triangle. In the next example, we're given that side AB is congruent to side AC, and that angle 1 is congruent to angle 2. We're trying to get to the point where we establish that line segment DB over FC is equal to BE over EC. Now, if we notice DB, and that correspondence with BE and FC and EC, you'll see that they're a part of the two smaller triangles in each of the bottom corners, just kind of almost a mirror image and then enlarged. So if we think about some of the theorems that we just talked about, is that if we establish proportionality, it establishes similar triangles. We can use that to establish the proportions. So what we're going to try to do is establish that triangle DBE is similar to triangle FCE. Then that will establish that the sides are similar. One of the ways that we'll try to do this is first establishing congruent angles. And the first way is to say the angle BDE and angle CFE are supplementary to 1 and angle 2 respectively. And since then they're supplementary and to congruent angles, then themselves will be congruent. Now, since we know that the bigger sides of this triangle, side AB and side AC are congruent, that also means that angle DBE, angle FCE are congruent. Now that in itself helps us to establish that the two smaller triangles in the bottom corners are similar based on the angle-angle theorem. So triangle DBE is similar to triangle FCE. Now based on that, that helps us to establish that DB over FC is equal to BE over EC based on the corresponding sides of similar triangles are proportional. And finally, our last example. We're given the diagram of the triangle on the right, and we're given that BE is parallel to CD, and we're trying to establish that BE over CD is equal to BE over AC. Again, this kind of comes from the proportionality, because if we think about the proportionality, that leads us to the mean extreme. I'm sorry, this should actually be multiplication. So the product of AB times CD is equal to the product of BE and AC. And again, that's going to come from the mean extreme, because if we have proportions, we know that if we multiply it out, basically cross-multiplying, that the multiplication will be congruent. So let's look at where those sides are. We have AB, we have CD, we have BE, and finally AC. Now, you'll notice that those sides are of the bigger triangle and the smaller triangle. So what we're going to try to do is prove that the smaller triangle is similar to the larger triangle, and that will establish the proportional of the sides, which will then establish the products being equal. So let's try to find angles that will be congruent. Since we know that BE is parallel to CD, we then know that the corresponding angles are going to be congruent. So angle C congruent to angle ABE, and angle D congruent to ABE. Again, based on two parallel lines imply corresponding angles congruent. Now, you could also say that angle A is congruent to itself based on the reflexive property, but that's not needed since all we need is two angles. So we can then go on to say that triangle ABE is similar to triangle ACD based on the angle similar theorem. From that, if we look at our triangle, what we can do is we can establish the proportionality of the sides being congruent. So AB over AC equals BE over CD, and that's because the corresponding sides of congruent triangles are proportional. And if we cross multiply, we see that AB times AC is congruent to AC times BE, and that's because of the means extreme product theorem that we learned a few sections ago.